Okay, this project is going to be a little different than the ones we've done so far, in that the game progresses on its own. You don't have to press anything and the game will just start going. Now you may have to press something to get the game started, but once it's started, the game will move every so often, and if you don't press anything else, you'll lose because the snake will hit the edge and it'll be game over. So this is different. This game progresses without user input. So you can kind of think of it like maybe it's approaching what we would call real time rather than turn-based. The way we're going to represent this game is very similar to what we've done before. We're going to have a nested arrays to represent our two-dimensional grid. We're going to have a board, which it'll be bigger than 4x4, but I just did a small example here. And that'll represent our board. We honestly don't even really need to represent the board in memory. Nothing really goes there. I guess you could add obstacles. Honestly, I don't think we even need a board object. But we need to know what are the edges of the board, what's the maximum number of rows, what's the maximum number of columns, just to make sure that we don't go off the grid. Unless you want to pass through a wall and come back on the other side, I'm not going to do that, though. I don't think that's a normal snake thing. So we're not going to do that. What we really need to represent is just an array, honestly, which represents the snake. And I don't have it listed here, but we're going to need probably an array for food, so that if you touch a food item, your snake will grow. And we'll get into that in a second. But so the main thing is really I just need to know how big my grid is in terms of number of cells, number of dimensions, number of rows and columns. And in memory, all I need to do is keep track of what cells belong to my snake. And I guess the first item will be the head of the snake. So the first thing on the list will represent the head. And I've colored it kind of light green here. And so this first element would represent the head of the snake. So we just need an array with coordinates in it, sets of coordinates, which represent where the snake's at. And it could be all coiled up, We also need to store the direction. So in this case, I would move up a row. Actually, I guess as positive, it would represent down a row if I'm doing row column. So in the next move, I would go. The head would be down here, and this body element should go to where the head is. So all we do for that is we remove the tail element, which was 1, 1, remove the last element, and then put it at the front, but make it now equal to the old head value, but add to the old head value the direction, so the row increases by 1. So it becomes, instead of 1, 2, it becomes 2, 2. And that's pretty much it. That's pretty much the movement of the snake game. We'll need to take some user inputs to affect the direction. And we probably want some checks to make sure that you can't you have your snake moving up and then you press down and your snake hits itself. We probably want to make only certain moves possible. So we need something to record direction and then some user input to affect the direction. But after that, the user doesn't actually make the snake move. The user just chooses the direction and the snake will make movements in that direction every so often, so at regular intervals in time. It doesn't do it when you press a key, it just moves all the time. You're pressing a key only changes which way it's going to go next time the clock ticks. That is pretty much it. The only other thing we'll need probably is a list of cells which represent where the food is, and whenever whenever the new head is going to go to where the old head is, whenever the only thing that'll change with the movement of this snake is if you is if there's a food in front of you, like let's say at 2-2, instead of removing the old tail element, we'll just do this. Let me make this a little thicker. If there is food there, we won't remove the tail element. We'll just add a new head. So if there's food right here and you're going down, a new head will form where the food was, and your snake will now be longer, one section longer. And now it'll be 3 in length. And that's it. That's all we got to do. So the main difference here, it's not that difficult of a game. The main difference is that this thing progresses without user input. So the timing of the game, the way time works, is the only thing that's different. So that pretty much gives us the description. We really only need 3 objects, maybe 4. I really just need the dimension size here. So I just really need one number, in this case 4, and that would control my edges. And then I need to know the snake array, I need to know the direction, and I need a food array. I don't have the food array listed. But that's pretty much it. So we'll start coding this in the next example.